Now we finally get to the part of the chapter that this chapter is all about, and that is solving systems of linear equations. A system of linear equations is simply two equations given to you together. And the goal is to figure out if there is a solution to the system. A solution to a system of linear equations is simply the point where the two lines cross. If you look at these three top graphs here, there are three options when we have a system of equations. The first is that when we graph the two lines, they will cross in exactly one point. These systems have one solution, and the solution is that exact point where they cross. Another thing that could happen is that the two equations are parallel to each other and they never cross. In this case, we say there are zero solutions or no solutions. The third option is that when we graph the two lines, they are exactly the same. So I cannot tell them apart. When that is the case, every single point on this line is a solution. So we say there are infinite solutions. Of course, we could never list all of these solutions. Here we would just say there are zero. Here we will actually list the point where they cross, which will be an x comma y. There's four methods to solving a system. There's graphing, there's addition, there's multiplication, and there's substitution. We're going to learn all four of these over the next 4 lessons. Today we're going to start with graphing. Graphing is the easiest method of solving a system, and all we do is simply graph both equations on our graph and find where the lines cross. So let's graph the top equation first. Remember, these are in y equals mx plus b form. So I always start with the y-intercept, the b, and then I use the slope to find the rest of the line. So for the top equation, the y-intercept is -2, so I make a point down here at -2. And then the slope is 5. And remember, if it's just a number like 5, we put it over 1, which tells us to go up 5 over 1. So I count up 5 and then over 1. That is my line. And now I'm going to graph the second equation. This one has a y-intercept of 4, so I start at 4. And the slope is -1. And again, when it's just a single number, I put it over 1, which means I go down 1 over 1. Down 1 over 1. So that's the second line. And you'll notice they do cross right there at 1, 3. So that is the solution to this system of equations. This is the only point that if I plug it into both of these equations, it would work. So if I took this x, which is 1, and plugged it in for x in this equation, I'd get 5 times 1 is 5, and 5 minus 2 is 3, and I get the y. Same thing with this one. If I plug the 1 in, I'd get -1 plus 4, which again is 3. And that is the only point that works in both equations. Here's example number 2. Again, I'm going to start at 3 for the top equation. And the slope again is 1, and we write it as 1 over 1, which means I'm going to go up 1 over 1. And sometimes it's good to extend the pattern on your graph out a little ways. My second equation, the y-intercept is -2, and the slope is -1/4, which means I'm going to go down 1, right 4. Down 1, right 4. Now you notice that's not going in the correct direction to cross with this line. So instead of going down 1 over 4, it's also okay to go up 1, back 4. Just continuing the pattern. And if you did it right, all 3 points should line up. There's the point where they cross at -4, -1. So that is the solution to the system. We always write the solution to a system as a point. Example 3, we have a y-intercept of 2, and a slope of -4, which I put over 1, which means down 4 over 1. So 1, 2, 3, 4 over 1. Connect those two. My second equation starts at 4, And it also has a slope of negative 4 over 1. So I go down 4 over 1. And you'll notice these two lines are parallel, which means they never cross. So we would say there is no solution. One thing that helps determine that there's no solution, if you look at the slopes, they are the same. Okay? Whenever the slopes are the same, it's either going to be parallel or it's going to be the same line. But we know these two aren't the same line because they have different y-intercepts. So if you have the same slope and different y-intercepts, that's no solution. If we had the same slope and the same y-intercept, so the two equations were identical, then we would say it has infinite solutions. Fourth example, we'd start at 3 in the first equation. The slope is 4/3, so I would go up 4 over 3. Now, that one went off the graph, so my suggestion is keep this pattern going in the other direction. So instead of up 4 over 3, I go down 4, back 3. Bottom one starts at negative 4, and the slope is negative 1, so I put it over 1. Be down 1 over 1, but that's not going in the right direction to cross with this line. So instead of down 1 over 1, I go up 1, back 1. Keep that pattern going. Up 1, back 1. Up 1, back 1. There's the cross. So the solution to this system would be negative 3, negative 1. So for solving a system of equations by graphing, you simply graph the two equations and then try to find the point where they cross. We have 3 options for your answer. They may cross in one spot, in which case you list the point x, y where they cross. They may never cross, and you say there's no solution. Or they could cross everywhere, meaning they're the same line, in which case we say there are infinite solutions.